Hi, we're going to be talking about the chemical level.
So everything that you have is made up of atoms. So everything, from the desk you're sitting at to the air that you breathe, it's all composed of atoms. And atoms join together to form chemicals or compounds, and each of those have different characteristics. Sorry. And the chemicals that they bind to and the atoms that actually interact is dependent on that characteristic of an atom. So some atoms really like to interact with other atoms just because where they sit on the periodic chart. Basically, they want to fill their outer shell with electrons. And that chemical characteristic determines the physiology at the molecular and cellular level. So inside your cell, there's lots of different chemicals going on, a lot of different chemistry that's actually occurring, and that depends on what kind of atoms that you have. And basically your body is made up of carbon, hydrogen, oxygen, and nitrogen, as well as a bunch of other minor chemicals, but those are the four basic ones. Protons are positively charged. They have one mass unit. Neutrons are neutral. They also have one mass unit. And electrons are negatively charged, and they're very, very tiny. Their atomic structures. This is a nice picture of a proton and a neutron in the nucleus, and the electron shell on the outer side, and electrons zipping around. And this is also hydrogen and 2 with electrons zipping around. But actually, not all. These are all actually nice examples of hydrogen. But if you notice, you can have no neutrons. So that's hydrogen 1 without any neutrons. You can have hydrogen 2 with a neutron, or you can have hydrogen 3 with 2 neutrons. And some really important, again, is oxygen, which is a component of water and other compounds. It's really very important. Carbon, we'll find a little bit later. We'll learn more about carbon. And carbon is essential for all organic molecules. And you might have heard the term organic to refer to organic gardening, but this is a different connotation of organic. Organic really means containing carbon. And then hydrogen also is a component of water and most every other component in the body. Another important is nitrogen. That's found in proteins and nucleic acids and other organic components. So those are the four major ones: carbon, hydrogen, oxygen, and nitrogen. Other important ones are calcium, and your mom or dad probably told you to drink your milk because it has a lot of calcium, and that's important for bones and teeth. It also plays a big role in the biochemistry of your muscle cells and your neurons. Phosphorus, which is also important in bones. Potassium, which is K. Potassium is found in bananas. And if you ever exercise, you might have to drink Gatorade after, because that potassium is really important for how your muscles function, and your nerves as well. Sodium, as well as potassium, they kind of go hand in hand. That's also important in muscles and nerve impulses. And chloride, or chlorine, which is important for blood volume and membrane function and bladder. Other ones are magnesium, which is a cofactor of many enzymes, and sulfur, which is found in proteins. Iron, so especially if you are a premenopausal woman, iron is very important because it plays an important role in your blood. So if you don't have enough iron, you might be having a little bit of, sometimes anemic, maybe a little bit dizzy. Iodine is important for your thymus gland, or thyroid gland, sorry. And other elements include fluorine, which is for teeth, copper, magnesium, manganese, zinc, lots of trace elements. So if you notice, all of these are atoms, but they're also minerals. So if you took nutrition, you might have already learned about the importance of these minerals. So minerals are elements. And if you take nutrition. Vitamins are organic compounds. So they similar in that they do similar functions in the body, but different other characteristics. Again, minerals are elements, and vitamins are organic compounds. So, okay, so atoms, as I mentioned, has many different energy shells. So those shells are the areas where the electrons really like to travel. So there's an inner one that only contains 2 electrons per shell, but the outer ones can contain up to 8. So the idea of chemicals that wanting to combine is they really want to fill that outer shell. So they want to get as many electrons in the outer shell so it can be full. So the idea is to get 8 in the electron in the outer shell. And that outermost shell is called the valence shell, and that's the most important one. So here's an example of hydrogen here. So this is the first electron shell, and this is helium. So hydrogen only has 1 electron, and helium has 2 electrons. So this shell is full. This one really needs another shell, another electron. So this is lithium again. So now you can see this is the same as in helium, and now we have a new shell because this one's full. So we go to the next level. And this has 1 electron, so this one needs 7 electrons to fill this shell. And here's neon. And this has all 8, so this is very happy. This one likes to react. This is not going to react with anybody. Okay, the lithium is the one that's going to want to react. Is the ionic bond here. Opposite charge, so they are attracted to each other. And so they actually, sodium chloride, if you add salt into water, you can see the salt disappearing. That's because the sodium kind of disintegrates. It really likes the water, and the chloride also. Okay, the next one is covalent bonds. And covalent bonds are good sharers. They share electrons. So that means that some of the time the electrons will be around one of the atom, and some of the time it will be around another atom. So they share. So an example is hydrogen. So we have electron that's sometimes around one and sometimes around another. So they share electron. Oxygen also can share 2 electrons. A big, really good covalent bonder is carbon. And carbon's very happy because it can receive or give up 4 electrons. So we'll see carbon having covalent bonds with many different partners. It's a good relationship, good sharer. Positive charge here and negative charge here. It actually interacts, has a kind of attraction. So people say hydrogen is not really a bond, but more of a weak attraction. So then this negative part of the oxygen is attracted to the positive part of the hydrogen. And this positive part of this hydrogen is attracted to the negative part of the oxygen. So each water molecule is attracted to another water molecule. Not very closely, just a nice weak attraction. And that gives it nice surface tension. We also have different states of matter. We have solid, which is a constant volume and shape. Liquid, which is a constant volume but changes in shape. And gas, which changes in volume and shape. So an example of that is water. Again, water we can have in the winter time here in Vermont, it's frozen. Sometimes in the summer, if we have a rough summer, hopefully not. In the nicer weather, it becomes liquid. But if you heat it up too much, if you're making tea, all that water evaporates and that turns into a gas. So everything has a solid, liquid, and gas phase. And then we'll kind of skip over molecular weights. It's just the sum of the atomic weights and its component atoms. So lots of things get together, lots of things cause reactions. So reactants are materials that go into a reaction, and products are materials that come out of a reaction. So in your body, you're always having lots of chemical reactions happening all the time. And so the total sum of all your chemical reactions is your metabolism. So that sometimes you're making things, for example, you might be making a protein, or sometimes you're breaking things down. You might be breaking maybe a carbohydrate down to get energy. Really interesting if you ever took physics. Pretty fascinating. So again, there are two kinds of chemical reactions. We can break things down, and that's called decomposition reaction, or we can build things up, and that's anabolism. So we can add two things together, such as A plus B, and we get AB, so we're building something. Or we can take AB and break it down, and that's A plus B. Or sometimes we can have exchange reaction. So we just take one and move it on to another. So we can have AB plus CD, now we have AD plus CB. So it just kind of switches around. And sometimes reactions are reversible. Sometimes it's really goes in one direction, it's really difficult to go in the opposite direction. So things can be moving in either direction. So these are chemical annotations. If you have a second, you can take a look at it. But sometimes reactions need a little bit of help. So at chemical reactions might occur maybe if the two atoms, the two molecules are in the exact right position, then you can have a chemical reaction. But many times they just can't get together. So I always think of this as a matchmaker. Matchmaker takes one reactant and adds whatever else. It kind of bends it or forms it in the right exact position you really want it, so that a chemical reaction can take place. So it actually reduces the amount of energy that's needed for the reaction to take place. And enzymes are always proteins. And so if you remember, proteins can be degraded. So that's one good thing you should remember about enzymes. So sometimes they're very sensitive with temperature, pH, and other chemicals around it. Okay, so here we have reactants. Here's energy here. So without reactants, we need a lot. Without enzymes, we need a lot of energy. But with enzymes, we don't need quite as much energy into the system to form a stable product.